NASA's Webb Telescope discovers possible direct collapse black hole. Imagine a cosmic mystery so bizarre, it challenges everything we thought we knew about black holes. NASA's James Webb Space Telescope has stumbled upon something extraordinary, a galaxy so peculiar it's been dubbed the Infinity Galaxy. But here's where it gets mind-boggling. Nestled between its twin nuclei is a supermassive black hole, defying conventional wisdom. Could this be the first glimpse of a black hole forming in a way we've never seen before? Let's dive into the details and explore why this discovery has astronomers buzzing with excitement and debate. As the Webb Telescope's data becomes publicly available, researchers are scouring its archives for hidden gems. Among them, Peter van Dokkum of Yale University and Gabriel Brammer of the University of Copenhagen stumbled upon the Infinity Galaxy while analyzing images from the Cosmos Web Survey. https archive.org ADS 2020-11-76. This galaxy stands out with its striking infinity symbol shape. Two compact red nuclei encircled by rings, likely the result of a head-on collision between two disk galaxies. But the real surprise? A supermassive black hole sitting between the nuclei, embedded in a vast cloud of gas. This unusual placement has sparked a bold hypothesis. The black hole might have formed directly from the collapse of that gas cloud, a process known as direct collapse. But here's where it gets controversial. Direct collapse is a theoretical concept often invoked to explain the existence of supermassive black holes in the early universe, but evidence for it has remained elusive until now. Peter van Dokkum, lead author of a peer-reviewed paper on this discovery, https www.stsi.edu/jwst/program information, explains why this could be a game-changer. Everything about this galaxy is unusual, he notes. Not only does it look strange, but the black hole's location and behavior challenge our understanding of how these cosmic monsters form. The traditional theories of black hole formation, light seeds and heavy seeds, struggle to explain the Infinity Galaxy's black hole. Light seeds start with small black holes merging over time, but this process is too slow to account for the massive black holes Webb has spotted in the early universe. Heavy seeds, on the other hand, propose that giant black holes form directly from collapsing gas clouds, but this mechanism has been hard to prove. Gas clouds typically form stars, not black holes, so something extraordinary must prevent star formation in these cases. And this is the part most people miss. The Infinity Galaxy might hold the key to solving this puzzle. Van Dokkum's team suggests that the collision of the two galaxies compressed gas so intensely that it formed a dense knot, which then collapsed into a black hole. Supporting this idea is the presence of ionized hydrogen gas surrounding the black hole, along with evidence of its active growth from X-ray and radio observations. But is this enough to prove direct collapse? Not everyone is convinced. Here's the debate. Could the black hole be a runaway from another galaxy, just passing through? Or might it belong to a third, unseen galaxy? Van Dokkum's team addressed these questions by measuring the velocities of the gas and the black hole. If their velocities match, it's strong evidence that the black hole formed from that gas. And guess what? Preliminary Webb data confirms that the black hole's velocity aligns perfectly with the surrounding gas, a smoking gun for direct collapse. But wait, there's more. The Infinity Galaxy isn't just hosting one supermassive black hole, it has three. Both galaxy nuclei also harbor active black holes, making this system a rare cosmic triple threat. While the team can't definitively claim they found a direct collapse black hole, they've eliminated many alternative explanations, strengthening their case. Now, here's the question for you. Do you think this discovery proves the direct collapse theory? Or is there still room for doubt? Could there be another explanation we haven't considered? Let's spark a conversation in the comments. This is one cosmic mystery that deserves a lively debate. About the author, Peter van Dokkum is a professor of astronomy and physics at Yale University. His paper on the Infinity Galaxy has been accepted for publication in the astrophysical journal Letters, and he leads Webb Director's Discretionary Program 9327, https://www.stsi.edu/program-information/programmed information. Dive deeper into the research by viewing or downloading the paper here. https://biopscience.io.org, article 10384-241. At Hadiki fi Parhisdam. James Webb Space Telescope discovers rare figure-8 galaxy with forming black hole. A cosmic enigma unfolds. Meet the galaxy with a black hole at its heart. Imagine a galaxy that defies the conventional norms of cosmic architecture. A swirling, figure-8-shaped wonder that has left astronomers awestruck. At its luminous core lies a mystery waiting to be unraveled, a newborn supermassive black hole shrouded in an aura of intrigue. This extraordinary discovery, made possible by the James Webb Space Telescope, has the potential to upend long-standing theories about the birth and evolution of black holes in the early universe. The Infinity Galaxy, a rare cosmic phenomenon. Led by Yale astronomer Peter Van Duchem, a team of scientists has stumbled upon this cosmic anomaly, aptly dubbed the Infinity Galaxy, born from the recent collision of two galaxies. This strange figure-8 structure is a rare sight in the universe. But what's even more remarkable is the presence of a supermassive black hole at its center, which seems to have formed in the midst of this galactic merger. A black hole in the making? While black holes are typically found at the heart of galaxies, this one appears to be in the process of formation, nestled between the two merging galactic cores. This is a first in the annals of astronomy, and scientists are eager to unravel the mysteries surrounding this phenomenon. This is as close to a smoking gun as we're likely ever going to get, says Van Duchem, the lead author of the study. Unraveling the mystery of supermassive black holes. The discovery of the Infinity Galaxy offers a unique perspective. Witnessing the birth of a supermassive black hole, the Infinity Galaxy discovery. Behold, a cosmic conundrum that has puzzled astronomers for decades. The birth of supermassive black holes. These colossal entities, weighing in at millions to billions of times the mass of our sun, are the gravitational behemoths that anchor the hearts of galaxies, orchestrating the dance of stars, planets, and luminous gas clouds. Yet the mystery of their origin remains unsolved. Did they emerge from a slow, methodical accumulation of mass, starting from a seed as small as a star's core? Or were they born in a dramatic, direct collapse of colossal clouds of matter, so dense that not even their own gravity could resist the inward pull? A recent discovery may have unearthed a clue that could unravel this cosmic enigma. In a pair of galaxies whose light has traversed 8.3 billion years to reach us, astronomers have stumbled upon what appears to be a supermassive black hole in the making. If confirmed, this would be the first time we've witnessed the birth of such a cosmic giant, a pivotal piece in the puzzle of supermassive black hole formation. Peter Van Duchem, an astronomer from Yale University, explains, "We believe we're observing the birth of a supermassive black hole, a phenomenon that has eluded us until now." This smoking gun was discovered in a pair of colliding galaxies arranged in a figure-8 pattern, reminiscent of the infinity symbol. Dubbed the Infinity Galaxy, this peculiar formation was identified during a search for cosmic oddities in the KWST Cosmos Web Survey. Each lobe of the galaxy hosts a brightly glowing nucleus, harboring a supermassive black hole. However, where the two lobes intersect, a third luminous blob catches the eye. Upon closer inspection, the researchers were astonished to find the telltale signs of a third supermassive black hole nestled right between the two lobes of the Infinity Galaxy. Van Duchem ponders, how can we make sense of this anomaly? A meticulous analysis of the materials surrounding the enigmatic black hole suggested that it was newly formed, residing in a vast region of hot, shocked gas. This discovery points to a novel mechanism for black hole formation, aligning with the direct collapse theory. In this scenario, two disk galaxies collided, creating the ring structures of stars we observe. During the collision, the gas within the galaxies was compressed and shocked, potentially dense enough to form a compact knot that collapsed into a black hole, explains Van Duchem. While such cosmic collisions are rare in the present universe, they were more common in the early epochs when galaxies were forming. Galactic collisions have long been theorized as a means for supermassive black holes to grow. When galaxies merge, their central black holes are inevitably drawn together by gravity. eventually colliding and merging to create an even larger black hole. This process is also thought to be crucial for the growth of galaxies in the early universe, with the Milky Way itself believed to have undergone multiple mergers. This hypothesis, while plausible, does not address the question of how the less massive, yet still supermassive, black holes at the centers of these galaxies came to be. The direct collapse model is gaining support, but direct evidence of this process has been elusive. The Infinity Galaxy, situated roughly halfway through the universe's 13.8 billion year history, provides a compelling argument for the direct collapse model at the dawn of the universe. The early universe was keening with dense hydrogen gas clouds and could have collided, creating shocked knots of matter in a similar fashion. This discovery is as close to a smoking gun as we're likely to find, asserts Van Dockum. 2 papers detailing this groundbreaking discovery have been submitted to the astrophysical journal Letters and are available on ARCID. This revelation not only deepens our understanding of supermassive black hole formation, but also invites us to ponder the vast mysteries that the universe still holds. What other secrets are hidden in the depths of space, waiting to be uncovered? And how will these discoveries reshape our understanding of the cosmos? Share your thoughts in the comments below.